it's an interesting conversation about data and data volumes, because geophysicists were dealing with this amount of data probably 5-10 years ago, and where we're heading now is that we're using a lot of that geophysical information, particularly in the 3D space, and a lot of the research and development, and certainly the funds, are being spent in this sort of world where research and development for geophysics hasn't been supported by the majority of the minerals industry in particular. Certainly it has been from the petroleum industry. And that leaves us in a bit of conundrum going forward, because as geophysicists, we've been looking at not only just cubical meshes to analyse and look at our data, but we've been looking at variable meshes and all sorts of aspects to it, but our codes aren't capable of processing that in a time frame that's certainly in the same time frame as what we're talking about here. Between acquisition in arrays and MT, and some of the processes alone are taking weeks. That's just in computational time. So it's a real interesting a space that we're moving into, particularly for geophysics. But what I thought I'd just talk a little bit about is just reducing the risk, and the art of targeting is a bit of a play on the art of war. And I guess I had a great introduction by BHP offering the 3 lines of defence, and then moving into the mineral systems approach, and then getting right the way down to specific targets. So I'd just like to talk a bit about that. So just a bit of a few words on interpretation versus targeting, what constitutes a successful or a quality interpretation, impediments to interpretation, speeding up that process, and just a bit of a wrap up. And the interpretation is the most probable geological explanation of geophysical data, and I'll put this in a geophysical context, based on prior information, or all the information you've got available to you, geochemistry, geology. And the target itself is the most probable interpretation that can be easily tested, that could result in an ore grade intercept. Now, it's an important concept to grasp because it affects the way we go about interpreting. Do we need to interpret all the data? What data do we use? Do we use big data? Do we throw everything at it to guide our interpretation? And anyone in here that's ever got the results of just a simple airborne magnetic survey knows that you can have up to 15, 20 images products out of that. And what value does that add to your interpretations and your targeting if you get that wrong, or just throw a lot of data in there? And then I guess, what processing products do we need to obtain the best possible targeting outcomes? We don't want a lot of false positives. We want to truly try and narrow in on finding the best area that we can quickly. So, and if we can't find that area that we really want to go and look into, then we can do all the exploration, apply all the science we want to it, but we won't be successful. So, we traditionally have been focused on the local to camp scale exploration, with no real true emphasis on the regional to continental context. But now we're through the mineral systems approach, and this is nothing new. The big companies have been applying this, but now we've got more nomenclature around trying to clearly define what that means, and if it assists us getting into the right exploration space, then that's important. And I really just wanted to show an example of data at a regional scale, and what data to use, and not necessarily give all data and input all data into some of our targeting concepts, but we need to use the right information. So this is just looking at the lower crust, and it's the government data, but it's been modified, and it's sampled at least 10 kilometres by 10 kilometres across the continent. And at first shelf, you might think it's just an off-the-shelf gravity image, but we've introduced the bathymetry data. We've added that to the gravity information. We've isostatically corrected the land data so that it merges well with the bathymetry data. So we cut out continental edge effects. We've essentially tried to remove the upper crust. We've taken off all the high frequency information so that we're focusing on geological areas of interest. We've put a gradient calculation over the top of that, and that's the black lines on the data. Very simple, but it's enabled us to just focus on large gravity gradients and see what's happening at that lower crustal level. And then we've used a bunch of algorithms that have implemented that, and this is all off-the-shelf software that's enabled us to do this. But in order to effectively put yourself in the right position, going through those steps and understanding your data and what you put in to your regional targets are important. And this is just the significant gold deposits of Australia. And you can see, a lot of them do cluster, and these are the black lines that you saw from the last image. And we do know there's trends, we do know there's lineaments, and it's certainly at crustal scale there are patterns and areas of interest which we should focus on. But we need the right data to do that. So, in my opinion, from a geophysical perspective, quality and successful interpretations are based on quality acquisition, and your highest priority projects in a geophysical portfolio are those where you're either acquiring data or you're in the process of drilling an area. I can't underestimate it. Same with geochemistry. The quality of the information that you're collecting in the field in real time, you've gone out there and invested a lot of effort to get it right. So firstly, make sure that you're collecting the right geophysical surveys for all the right reasons, but then make sure you're getting the best quality data possible while you're out there. And coming from a big company background now to a consultative perspective, there's a reluctance to want to make sure that the data that is collected in the field is absolutely the best data you can possibly collect. Petrophysical data, and I'll give some examples a little bit later on, is fundamental to any interpretation, but more importantly to survey planning. If you don't know the target that you're after and what those petrophysical properties are, then you're gonna lack in your understanding of targeting and your ore body model of what you're after. And more often than not, geophysics is mapping alteration. It really doesn't care about the geology. The biggest gold deposits in the world have a petrophysical contrast which is different to the lithological one, and often the samples are taken for petrophysics are trying to sample each of the different geological components of it, but we really should be focusing on the alteration. And that leads into the next point, consider alteration versus lithology. We need to separate fact from inference. Quality acceptance of interpretation can significantly improve if we've got all the factual information. That goes for geological and geophysical information. And the presentation of the data, I can't underestimate that. Key concepts and ideas are presented in a way that's easily understood. And this could be 2D section plan to 3D. But if you can't get your concept or grasp or present what that target is, then it'll never get tested and funded. And then it's iterative. Good interpretations are reviewed and reassessed as new data becomes available. And I just wanted to give just a bit of an example here of just interpretations. And on the left there, you can see a first vertical derivative magnetic image, and we'll go about our business of processing and looking at the magnetite content in that, which is all dominantly magnetite, identifying lithologies in that and structural breaks within it. The alteration in areas would have, demagnetized certain portions of it, which may or may not be associated with mineralisation. But the critical targeting framework is over and above the standard interpretation. So on the right, we can see some red lines, and the northern red line is the basin boundary between the sediments and the dominantly mafic volcanics. The second red line down the bottom separates the lower mafic, ultramafic stratigraphy, which has been separated by a unconformity, and that unconformity has been identified by a number of units juxtaposed to that, and there's a fold and in here in the centre, these are fold axes, so these are repeated, all these units through here. There's another upper and lower unconformity in black. The other thing on here is interpreted intrusions in red. So once you bring in all the components of your interpretation, your targeting becomes a lot more specific and focused. So you need to understand what your outcomes are going to be as you're interpreting. So that gets back to your data. And here's another version of the data, but in this case, we've used the Centre for Exploration Targeting, a texture-based filter analysis. And this is just a heat map, and this is one of the components that's in Geosoft that highlights the density of changes in structural orientations and contacts. So what we've done was statistically taken the data on the left and applied a certain amount of this filter to it, and it just looks at different orientations of contacts and the structural orientations. And so this becomes a form of your target map. And it's an important part of using these types of filters and systems as just another image like that one on the left. You use it to inform your targeting, but in this case, there's a whole bunch of near-surface noise which is associated with the regolith and the lateritic, and this is taking away at least a third of the targeted responses just due to the near-surface laterite response. Specifics you can get into. This is mineralised here. It's the third biggest gold zone in this belt, and then down to the south here on the biggest producing gold mine, there's nothing. So there's pros and cons of using these approaches, and they need to inform one another. So taking this interpretation a little bit further and using that to inform where to target. On the left here, this is work by David Groves, and he's looking at greenstone-hosted gold in the Archean, dominantly associated with these later events, and he demonstrates that in his paper. You need to be within these regional big shear zones with cross-cutting, facilitating structures in the right host rocks and proximal to the big deposits. And here is the example of the mineralisation to some potential targets associated with that. Interpretation impediments, poor acquisition legacy data, and survey design that doesn't address scale and or the petrophysics. And the lack of geological experience and support. There's no interpretation. Again, this is from a geophysical perspective. There's no interpretation overlap with the geologists, and that can be said for the same for the geologists with lack of geophysical understanding. It's important to have that integration and overlap for the best targeting. The lack of petrophysical data in helping your interpretations. The increased complexity of acquisition and processing. With geophysical data now, we're not necessarily collecting data in the old-fashioned way along a line, particularly for IP. We're collecting arrays and also with MT, and the time series and data associated with inverting those large 3D surveys are approaching that of seismic. And also the appropriate meshes that replicate geology and geophysics inversion parameters are important, as I mentioned earlier. The lack of time, other demands on time and processing, interpretation platform and presentation of results and how these are delivered. You know, we need to have that totally integrated and with variable meshes and other aspects of how we're processing data need to be considered. So I just wanted to show a quick example from Nevada where alteration and porosity alone explains the geophysical response, not necessarily anything to do with the host rock geology. Up here we've got the Getchell Turquoise Ridge deposit. It's 26 million ounces, and just 5 mile away is the Twin Hills deposit. Cumulatively, that's 45 million ounces in about a 10 mile square radius. You know, there's a whole bunch of surveys being collected across here, but this is an MT inversion of the 3D data. There's MT and CSAMT data gone into here. The red dots in the middle here coincide pretty nicely with the bulk of the mineralisation and the alteration. There's another one over here which is altered rocks, but it doesn't contain any gold. You know, and to understand this, and the petrophysics was done prior to that survey, so we wanted to demonstrate, you know, what types of techniques we could use in this environment. And on the left here, we've got resistivity. So the resistivity increases, and that was a conductivity low, or it's conductivity high. So this increases in resistivity on this axis, and this is just the different rock types. So all the gold is hosted in the most resistive rock types. So those alone weren't an explanation for the section that you saw previously. What you see now is the different alteration that is associated with the kaolin mineralisation. Argilisation, this is low in resistivity. Decarbonisation is lower, it's at this other spectrum. And silicification is sort of a modest sort of response. So we wanted to be definitive about where the gold sit, and it was in this low end. The gold here is in the colours, the low resistivity, the high resistivity to the right, confirming that all the gold sits in the low resistivity, and then we use the petrophysics to confirm that it was associated with alteration, not necessarily the host lithologies. So it was important for a successful survey. How to speed up interpretations, and you know the best interpreters aren't necessarily acquiring data when it comes to geophysics, and that's not always the case, but it's a good outcome. Well documented and processing workflows for common techniques. So often you get geophysical data coming from contractors in different formats, and there's all sorts of things, and that just goes across the board for geosciences. But if we document these and have these workflows for common techniques, it certainly helps us streamline the process. Embedded specialists and champions, internal, external to the company, portions of workflows outsourced to keep focus on interpretation. And you know, when it comes to geophysical data, it's often a specialist task, particularly with inversions, and it's good to have everyone across it, but certainly when it comes to the pointing end of getting embedded specialists and champions that know how to run inversions and know how to do it well, working with people that don't is important. You get way better outcomes. Introducing good geological constraints at an early stage of the interpretation. We can decrease our processing time with more efficient codes and access to clusters, and this is what we're doing daily now. There's open access to Azure. And one of my biggest things that I, not only from a big corporate perspective, but from a consulting perspective now, is the use of commercial software allows better integration of all data. there's nothing worse than seeing 5 bits of software being used to reduce data to put into the bit of software that you want to do your interpretation on. So, having commercial software that enables you to have it maintained, updated without doing it internally or in-house, I think will assist in speeding up the interpretations. And I'll just show you a quick example of where we're heading sort of with geophysical acquisition on a larger scale, if you like. This is an example from Alaska. We've got some sediment-hosted copper mineralisation here, some quite significant grades and not too bad thicknesses. And there's a bit of drill core here which would be pretty conductive when it comes down to an EM response. And as a result of an EM crew sitting out there not getting a response, the client called up and said, "What's going on?" This wasn't with our planning, by the way. We've taken a look at the petrophysics to see what response we were going to get, and when you looked at the inductive conductivity of these core samples here, we only had a select few. It became apparent pretty quickly that not only is there a lack of inductive conductivity response, but it was a modest resistivity response of 50 ohm meters and 24 ohm meters respectively, but it had quite an IP response. And one of the biggest contributions to that was this sedimentary foliation that you see and how the massive chalco was emplaced. So to help and assist targeting, a 3D IP survey was done. This is about 6 kilometres in width by 3 kilometres wide. We've used a dipole spacing of 100 metres, inline receiver spacing of 200 and 100 respectively. Some of the impediments to acquiring that data was pretty steep, and it took a reasonable amount of time, but in essence, the 3D array, or the ability to take data in 3D is far quicker than the old standard linear or line approach. We've inverted these data, 25 by 25 metre cells in X and Y, 12.5 metres in depth. We've got over 3 million data points in here, of which we had to invert. And when we do the resistivity inversions, every one cell for the resistivity affects another cell. So computationally, this took about 5 days just for each iteration. And how often do you get it right on the first go? Hardly ever. So we run multiple versions of this, and we've found ways in more recent time to be more efficient with this processing, but certainly it was a struggle at the time. Some of the outcomes were here. We've got a highly chargeable volcanic sequence, and we have some sediments in this blue with our main target areas highlighted here in black, which this is chargeability, and this is 100 metres beneath the surface. We've integrated that with the soil geochemistry and have targeted the central zone as a starting point. The known mineralisation is here in red. And this is just a graphical display of some of the drill holes and some of the early results that was achieved. And there was 14 metres at 10% copper focus targeting on some of the IP results. So just in summary, be clear on the results of the survey and what the survey is trying to achieve. It's important to get it right. But don't let interpreters too get involved with the execution, certainly in the planning. Have routine, regular processes and workflows that can help you expedite the process. Understand your petrophysics and integrate with the geology early, so it's good context and framework for a lot of the interpretations. And the presentation and delivery of the results can be the difference between a good interpretation and a bad interpretation. So just a quick acknowledgement and thanks is the Terra Resources team, Alto Metals and PolarX for the examples, and Geosoft and Seequent for letting me come today. Thank you.